So as you might know, we launched the new machine learning specialization just some weeks back. So I want to show you a quick demo of this. Let's see, we're working last night to figure out what exactly to demo. So not entirely sure that everything will work, but we'll find out. All right, cool. So many are familiar with the experience on Coursera of video lectures, programming exercises, quizzes, and so on. What I want to do was share with you some of the pieces that we're working on that we're most proud of, which is the labs and the visualizations to help learners hone intuitions about machine learning. When I was learning this stuff, for the first time, I had to implement a lot of algorithms, try this, try that, try a lot of things to see how they work. And so we put a lot of effort in the machine learning specialization to build a lot of labs in order to let you try different things very quickly to hone intuition. So for example, this is actually a demo of linear regression. So where the little red crosses are the data points, and by clicking different places on this diagram on the right, you can try out different values of the parameters of the model for linear regression and visualize the cost function and how varying the parameters lets you fit the model differently. And again, cost functions is sometimes a mysterious concept in machine learning, because our team tried to build visualizations like these to help you quickly dive into it and kind of see how these algorithms really work. So let's see. All right. So bring slides, please. So the newly launched machine learning specialization is a specialization of 3 courses, where in the first one, you talk about regression algorithms, making predictions where the output you're trying to predict is a real number, like predicting housing prices, as well as classification problems, and then also lots of tips and details and algorithms on how to train your model, algorithms like gradient descent. So the first course in 3 weeks, you learn how to build your own machine learning model. The second course is on more advanced learning algorithms. So starting off with what are neural networks, and then how do you train a neural network? Neural networks, deep learning. How do you have an algorithm input a picture of a car or a handwritten digit and tell you what it is? And then you learn lots of practical advice for how to build these things. So rather than just knowing the algorithms, how do you use the algorithms effectively? I think of machine learning as a tool, and like a hammer or a drill or a saw, you don't want to just have the tool. You get the tools from the course, but something relatively, maybe a little bit unique to this specialization, to the courses I've taught still, is spend a lot of time on practical advice on how to use the tools. And then also, decision trees was a new topic added, since it's a cutting edge technique that is used in many commercial applications. And walk through a fun example, trying to figure out if an animal is a cat or a dog based on different attributes of the animal, like ear shape. Is it pointy or floppy ears? Hopefully, if you take the class, you have fun seeing that. And then finally, the third course starts off with unsupervised learning. So how do you learn without labeled data? So clustering algorithms used for market segmentation or anomaly detection. How do you figure out that something is wrong from without labeled data? Recommender systems. So how do websites like Amazon and Walmart recommend products? How do websites like Netflix and YouTube recommend movies? How does that technology, which is commercially very important but a bit underrated, actually work? And then also wrapping it up with reinforcement learning. We had a very basic. I'll share a little bit more of a demo of that in a second. And so what we did in updating the specialization, excuse me, just sharing my screen again, was take all of the exercises that a decade ago we designed to use MATLAB and Octave, and we did everything in Python, which is really the modern language of choice for machine learning developers. And then also, I rethought what are the most important topics, like the latest tools, like TensorFlow and modern neural networks and decision trees, and redid the content of the specialization to capture best practices in modern machine learning. Other examples of labs. So this is a data set. Let's add some data. Positive examples is red. Let's add some blue dots. So ignore the red dash curve, we'll explain in the lab. But with this, let's fit a linear model, first degree polynomial, or let's fit a second degree polynomial, or let's fit something really big and complicated, a fifth degree polynomial that it starts to overfit. And so in just a few weeks, you will be able to read through and understand this code, or also implement algorithms like this yourself and have very interactive labs that we spend a long time building to hopefully make it time efficient for anyone wanting to learn this for the first time. Or neural networks. This is handwritten digit classification. So by the second week of the second course, you know exactly how a deep learning algorithm, how a neural network works, and be able to implement it yourself. And so, I've already run this notebook, but to run some predictions, let's see, it is now 11:27 where I am in California. I've never seen this example. So okay, it's an image 2, and the neural network reads this image, is able to predict that this is a digit 2. So by the second course, you know how to build all this yourself and have a neural network able to take as input a picture and make a prediction. So a lot of the labs like this is what makes it easy and hopefully fun for you as well to try out things and get hands-on and do lots of projects and get the hands-on experience. I'll just show one last fun one. We wrap up the course with a set of lectures and then also a lab in reinforcement learning. And so earlier this morning, I used the lab and I set the parameters badly to train a lunar lander simulation that does poorly. So I deliberately set the parameters badly. But when I do that, this is a little lunar lander trying to land on the landing pad between the two flags and the trashes, all right, to scale. But what you do, if you take this specialization, is you learn how all this stuff works, and hopefully you'll be able to get the algorithm right and get this lunar lander, get this poor little lunar lander to actually land where it's supposed to, between the two yellow flags. So I hope that if you yourself or your friends are interested in learning about machine learning, the updated machine learning specialization will be a good place for you to learn and dive in and do lots of fun projects. In just 10 weeks, you'll be surprised at how far you can get. And lastly, I just want to acknowledge the team that had done a lot of the work that made this possible. Eddie Shu is the curriculum architect, worked closely with RT Bagu, Jeff Ludwig, Andres Castillo, Tin Cheng, Robert, and then also many others that were the team. And I actually had a lot of fun spending many, many hours with the team debating, how do we explain this to make it more efficient and clearer for anyone wanting to learn this? And so I hope that you either take it yourself or encourage your friends that could benefit from learning about machine learning to jump in. So thank you very much.